Let's take a look at geometric sequences today. And so in the past we looked at arithmetic sequences where you're adding a number or subtracting a number each time to get to the next number, to the next term. With geometric sequences, well, here's the definition. It says the ratio between two consecutive terms is always the same. In other words, in order to get to the next term, you multiply by the same number. So here's an example to try to explain what I'm talking about. It says, what's the common ratio for this geometric sequence below? If we were doing an arithmetic sequence, we would say, well, this one goes down by 2.5. This one goes down by 1.25. And this goes down by 0.625. And we notice these aren't the same difference. So it isn't an arithmetic sequence, obviously, because you're not subtracting the same number, and that should have been negative. So, but that's not right, so we don't want to do that. So let's look at it a different way. What are we multiplying by to get to the next one? So 5 times 1/2 will give us 0.25 and 2.5. And 2.5 times 1/2 is 1.25. And 1.25 times 1/2 is 0.625. So our common ratio, and same thing here, our common ratio here is 1/2. So R equals 1/2 in this case. One way to do this, if you're not sure how I got 1/2, if you take any term, we'll take the second term, and divide it by the first term. So we could do 2.5 divided by 5, and that gives us 1/2. You could also do 3.125 divided by 0.625, and that would also give you 1/2. Okay, so let's take a look at an example here. It says a recursive formula is given for a geometric sequence. Find the explicit formula for that same sequence. So what I'd like you to do is pause the video now and try to come up with this answer before I show you how to do it. So pause it, and when you restart it, I'll show you how to get the answer. Okay, so this tells me first term is 3. And then this tells me I should do the previous term times -2. So that means 3 times -2 is -6. And then I'm going to take the previous term, which is now -6, multiply that by -2. So -6 times -2 is +12. Okay. Then we take +12 times -2, we get -24, and so on. Okay, so the question is, how would we write an explicit formula so that if I just type in n to my formula, it's going to give me each of these numbers. So when n equals 1, I'll get 3. When n equals 2, I'll get -6. When n equals 3, I'll get 12. When n equals 4, I'll get -24. And when n equals 5, I get 48, and so on. Okay, so let's look and see what's happening here. From first term to second term, we're multiplying by -2. From second term to third term, we're multiplying by -2. From third to fourth, we're multiplying by -2. And so if we look at our fourth term, for example, on our fourth term, we've multiplied by -2 3 times. And so to get to -24, I'm going to be a little bit, I don't know, lengthy in my explanation how to get to this. We'll do purple here. So to get to -24, we did 3 times -2 times -2 times -2. An easier way to write this is 3 times -2 to the third. So in general, to get to, let's say we want to get to the 50th term, well, if this is the fourth term, this would term 4, would be 3 times -2 to the third. For the 50th term, it stands to reason that this would be 3 times -2 to the 49th. So in general, our formula is 3 times -2 to the n-1. I don't know if you want to put this in parentheses to remind yourself that the n-1 is the exponent. All right, so let's look at the next slide. This is kind of our general formula for the nth term in an explicit geometric sequence. So it gives you, this is the starting value, this is the common ratio, which you're multiplying by each time, and then the exponent is n minus 1. So this is just kind of our general formula. We kind of came up with this on the previous example, but in general, this is how you would do any geometric sequence explicit formula. Okay, so I've got 3 examples here. It says find the missing values of the geometric sequences below. And so we know it's geometric, so we know it's multiplying. If this said arithmetic, then we'd know it'd be adding. But since it's multiplying, they're going to be different numbers. So we did this with arithmetic sequences. Let's do the exact same thing. So we know we're going to do 6 times the ratio is going to give us this number. And then we're going to multiply by the ratio again to get this number. And then we're going to multiply it by the ratio again to get this number. And then we're going to multiply by the ratio again to get this number. Okay, so let's set up an equation. We're going to do 6 times r times r times r times r, so times r to the 4th, will end up giving you this number, 1536, 1536. Okay, so let's solve this. We divide by 6, and we get r to the 4th equals, and I'll bust out my trusty calculator, 1536 divided by 6, and I get 256. So this is the rate to the 4th power. It's 256. So to undo the 4th power, there's a couple ways to do it. You can do the 4th root. The other way is you can do it to the 1/4 power. So in my calculator here, to do the 4th root, ooh, what's going on? We'll hit 4, and then math, and then the 5th one down is x square root, and then we're just going to type in 256. There we go. So the 4th root of 256 is 4. All right, so that means our rate is going to be 4. So that means that's what we're multiplying by to get to the next term. So 6 times 4 is 24. 24 times 4 is 96. 96 times 4, let's see, that'd be 400, take away 16, so 384. And then 384 times 4 is 1536. And I just want to verify that. 384 times 4, there we go, 1536. All right, so what I'd like you to do, pause the video and try these two on your own. See if you can come up with a common ratio, and then come up with these blank terms. Okay, so via magic, here are the answers. The rate in this one was 0.1. So the second term is 1500, the third term is 150, the fourth term is 15. And in the last one here, the rate was 0.5 or 1/2. And the first was 216, second was 108, 54, 27, 13.5, 6.75, and 3.375. Okay, so last idea for the day. It says in a geometric sequence, the 5th term is 81, and the 8th term is 2187. It says figure out the 2nd term. So what we're going to do is we're going to just kind of draw some blanks here. And I don't mean like just space out and forget everything. We're going to say this is term 5, term 6, term 7, this is term 8. So I'm pretty good at number lines. I know that this would be term 4, this would be term 3, and this would be term 2. So we're going to kind of ignore these 3 to start with. We're just going to work with term 5, which is 81, and term 8, which is 2187. So right now, if we just focus on this part, it's exactly what we had just done. So we got to figure out the common, we got to figure out the common rate. So from here to here, what did we multiply by, and what did we multiply by, and what did we multiply by? So it's 81 times r to the 3rd equals 2187. Okay, we divide by 81. Oops. We get r to the 3rd equals 2187 divided by 81. 27. Wonderful. Okay, so r to the 3rd is 27. If we do the 3rd root of both sides, we get our common rate is 3. Okay, so we do 81 times 3. We get 243. Then we times by 3 again, and we get 729. So 243, 729, and then 729 times 3 is 2,187. Okay, so if we want to figure out term 4, instead of multiplying by 3, to go the opposite way, we're going to divide by 3. So 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So the second term is 3. All right, so that is it for geometric sequences. Now, one thing I do want to point out on this previous slide, I'm realizing I made a little bit of a mistake. If we do the fourth root of r to the fourth, if we do, let's kind of think back to earlier in the year. If we do r squared equals 4, we square root, we get r equals plus or minus 2. So really our rate could be plus or minus 4. So there are two possible answers. There's this answer, or there's also negative 24, positive 96, negative 384, positive 1536. The same thing would be held true for the second example. So this would be plus or minus 1500. This would be 150, and this would be plus or minus 15. And then the same thing down here. Now the only time where this wouldn't happen is, and so maybe I should do that here, plus or minus 108, plus or minus 27, plus or minus 6.75. When you don't have to worry about the plus or minus is a case like this, where the third root is always the same sign. So if this was negative 27, then the third root would be negative 3. You don't have that plus or minus situation with r to the third or r to the fifth or r to the seventh, stuff like that. Okay, so now truly that is it for geometric sequences. I hope you enjoyed.